With question 1, we should identify that this is a fairly straightforward equation where we can simply factorize. And so if we have to factorize this trinomial, we would find that it's going to be x minus 4 and x plus 1. Then I can say that x minus 4 must be equal to 0, or x plus 1 is equal to 0. And so we can find that x is equal to 4, or x is equal to minus 1. In question 2, you need to move everything over to the one side, make the other side equal to 0, and then you can factorize. So we would make two brackets, and if you had to factorize this trinomial, you'd get x minus 8 and x plus 1. Then you could say that x minus 8 is equal to 0, or x plus 1 is equal to 0, and so that's going to finally give you x equals to 8, or x equals to negative 1. Question 3 is fairly straightforward, but there is one area where students can make a mistake, and that's because this specific trinomial has something pretty weird that's happening. Check this out. We know that to find the factors of 6, it's going to be 6 times 1 and 2 times 3. Now, both of those could give you a 5. See, because we're trying to make 5, because 6 and 1 can definitely make a 5, and 2 and 3 can also make a 5. Let me show you why using this option would be incorrect, because you would have made two brackets and you would have said x minus 6 and x plus 1, because minus 6 plus 1 is minus 5. But if you had to multiply these two parts together over here, that would give you a negative 6 and not a positive 6. So I hope you can see that that option does not work. So now obviously it's going to be this option over here, so we're going to open up our two brackets and we're going to say x minus 2 and x minus 3, because minus 2 minus 3 is minus 5, and then if you had to multiply minus 2 with minus 3, it's going to give you positive 6, which is what we have there, so that's all good. And then we can say equals to 0, and then we can say that x minus 2 is equal to 0, or x minus 3 is equal to 0, and so x is equal to 2, or x is equal to 3. In number 6, we have been asked to solve this equation, but we have to use completing the square. Now remember, there are multiple ways to solve equations, but you want to try become good at all of them, so that if in the test or exam they ask you to use a specific technique, then you know what to do. Now guys, please bear with me here. Your teacher might do completing the square in a different way to what I do. You do not have to follow your teacher's way, and you also do not have to follow my way. You must choose whichever way you are comfortable with, okay? Just make sure that you're getting to the same answer, because as I said, there are different ways. So what I would do, and what a lot of students do, is they would take the 10 over first, then we can open up a bracket like that, and then we're going to take x minus, now you must always divide this number by 2, so that's going to be 9 divided by 2. Okay, now you might have another step in between. Okay, I know some students do it like that, but I'm just using the shorter method. And so then on the right hand side you're going to say 10, then you're going to say plus, then you're going to put this number into a bracket, squared. If you can remember this pattern, you can do really well with completing of the square. Let's go through that carefully. What did we do? So what I did first was I took the 10 over, that was this step here. Then I open up a bracket and I put a square, and then I take this number and this number divided by 2. Then I put the 10 over here, because that 10 was already there, and then I add whatever this number is in a bracket squared. That is all that you need to know for completing the square. The next part's very easy. So, and bear with me guys, we're going to do a couple of these questions, so if you're still struggling a bit with these, try a few more examples and then you'll start to see the pattern. So now what we do is we say x minus 9 over 2 squared, then this number on the right, you just type that all in the calculator using the brackets wherever you see brackets, and it's going to give you 30.25. What you now do is, to get rid of the square, you're going to square root both sides. So you square root both sides, because in maths you can do whatever you want as long as you do it to both sides. So you should know by now that a square root is the opposite of a square, so it almost cancels it out, or it cancels it out completely, so that all that we'll be left with is the x minus 9 over 2. And then what I forgot was that you always want to say plus minus over here. Now if you take the square root of 30.25, it's going to give you 11 over 2. But then always remember plus minus. Then you can get x alone by saying plus minus 11 over 2 plus 9 over 2. Now we can go ahead and get our two answers. So for our first one, I'm going to keep this as a positive. So that's going to be 11 over 2 plus 9 over 2. And that's going to eventually give you 10. Or you could say x is going to be the negative option, which is going to be minus 11 over 2 plus 9 over 2. And that's going to give us negative 1. And so our two answers are going to be x is equal to 10 or x is equal to negative 1. Here is another completing the square example, and what I said in number 6 was that each teacher does completing the square there's different ways of doing it. So you might not like the way I do it, or you might not like the way your teacher does it. You must do whatever's comfortable for you. You will still get to the same answer. So the technique I like to use is I take this equation and I move the constant over to the other side. Then what I do is I open up a bracket and I take x, and then I take whatever this number over here is, but I first divide it by 2. So it's going to be minus 5 over 2. How easy is that? Then on the other side I've still got the 14, and then all I do is I plus, then I open up a bracket and I put this number inside the bracket and I square it. That's the most difficult part. From this point on it's easy. I then say x minus 5 over 2 squared. Then I type all of this exactly as I see it on my calculator, and it's going to give me 81 over 4. Then to get rid of this square, I'm going to square root both sides. And then remember that the one on the right, you're going to use plus minus. And then as we said, this square root is going to completely get rid of the square. So all that we're left with on the left is x minus 5 over 2. And then on the right hand side we're going to have plus minus. Now the square root of 81 over 4 is 9 over 2. Then I can get x alone, like that. And then I can get my two answers. So for the first answer I'm going to keep it as a positive. So it's going to be 9 over 2 plus 5 over 2, which will give you 7. Or, now I'm going to use the negative. So that'll be negative 9 over 2 plus 5 over 2, which is eventually going to give us negative 2. And so our answers are going to be x is 7 or x is equal to negative 2. Here's another completing the square example. So as I said in number 6 and number 7, your teacher might do this in a slightly different way to me. You must just choose whichever method is comfortable for you. So in my technique, what I like to do is I move the 5 over to the other side. Then I open up a bracket and I put the x, and then I take this number and I divide it by 2, like that. Then on the other side I say 5, because there is a 5 there. Then I always say plus. Then I open up a bracket and I put this number in the bracket, squared. Okay, that's all you need to know. Then from this point onwards it's very easy. I rewrite this part and then I type all of this on my calculator, which is 29 over 4. You can write it at as a decimal if you want to. That's absolutely fine. And then what I do is I take a square root on both sides, because I know that a square root will help me to get rid of the square. Then on the right hand side one I must say plus minus, like that. And so on the left hand side the square root is going to be gone, so we're only going to be left with x minus 3 over 2. And on the right hand side we're still left with plus minus square root of 29 over 4. 29 over 4 is not a nice number, so I'm just leaving it like that for now. Then to get my two answers I can take the 3 over 2 over, so we're going to end up with this, like that. So our first answer will be when this one is a positive, so I'm going to go 29 over 4 plus 3 over 2, and that's going to give us, be careful not to type the 3 over 2 in the square root as well when you're on your calculator, and that's going to give us 4.19 if you're using 2 decimal places. Or now we're going to use the minus, so that's going to be minus square root of 29 over 4 plus 3 over 2, and that'll give us negative 1.19. And so those are the two answers for this question. Here is another completing the square example. So here we go. So remember what I usually do in our other previous completing the square examples is I like to always take this number over to the other side, but it's already on the other side for this example, so we're going to go straight from here. In case I'm confusing anyone, what I mean is the following. If they gave it to us like this, I would have first moved the 11 over, okay? Then our next step is usually to open up a bracket, and then you say x, and then you take this number and you divide it by 2, so that's going to be minus 10 over 2. And then on the other side you say 11 plus, then you open up a bracket, squared, and you put this number inside that bracket, so minus 10 over 2. Now, if you know what this number is, for example, we all know that that's minus 5. You can say that. Don't worry about having to keep the 2 there. The reason we did that on the previous questions was because it was a number we didn't know. Then on the right hand side, we want to type all of that in on the calculator, which will give us 36. Now what you do is you take the square root on both sides, and then on the right hand side, remember to say plus minus. Okay, so now we've got x minus 5, because the square root cancels out the square, and then on the right hand side, we're going to have plus and minus 6. So this means that x will be equal to plus and minus 6 plus 5. So if we go get our answers, we'll get that x is equal to 6 plus 5. That's by keeping it a positive. Or, now we can use the negative one, x is equal to minus 6 plus 5. So x is going to be equal to 11, or x is going to be equal to negative 1. In number 10, I want you to make very sure that you understand what I'm about to say. You cannot do completing the square if the number in the front is not a 1. You know how in all the previous examples we've done, they've all looked something like this, or maybe like this. See how the number in the front is always a 1? That is a golden rule for completing the square. So we need to divide everything by 2. Okay, so that's going to let us end up with x squared minus 4x, because I divided by 2, and then minus 7 over 2. See how I did? I divided everything by 2. Now we can carry on like it is a brand new question. So if you watched my previous completing the square videos, you would know that I like to always put the constant on the other side like that. Then what I do is I open up a bracket and I divide this number by 2. So that's going to be 4 divided by 2 squared. Then on the other side I've got a 7 over 2, and then I say plus, then I open up a bracket to the power of 2, and I put whatever this number is inside there. There we go, that's the difficult part. Now it's easy. Now if you want, you can realize that this is positive, it equals 2, right? 4 divided by 2 is 2. So you can write it as x minus 2. You don't have to keep the fraction if you don't want to. And then, on the right hand side, we're just going to go type all of this in on the calculator exactly as you see it. And that's going to give us 15 over 2. If you want to write 7.5, you can. Then what I'm going to do is I'm going to square root both sides. So, because I know that a square root will get rid of this. So that's going to look like this. But remember that when you square root the right hand side number, always say plus and minus. Now, this square is going to be cancelled out by the square root, and so we're literally going to be left with x minus 2 on the left, and then plus minus the square root of 15 over 2 on the right hand side. Then to get x alone, I'm going to take the 2 over, so we're going to end up with this, like that. And so our first answer we can get by keeping this a positive, so that's going to be square root 15 over 2 plus 2, or x will be, now I'm going to use the negative, so it's negative like that, and then I'm going to say plus 2. Okay, so now it's a matter of just typing this on your calculator, and that's going to give you 4.74, or negative 0.74, and there's our two answers. In question 15, you should identify that there is a fraction. Now, two things, guys. With a fraction, you need to get a lowest common denominator. And the second thing is you need to see that, well, remember, you can never divide by a 0. So we don't ever want this to be equal to a 0. So let's go see what x would have to be for that thing to be a 0. So we'll quickly say that 2x minus 1 is equal to 0, and then 2x is equal to 1, and so x is a half. So what that means is that when we get our answer later on, we must make sure that x is not equal to a half. Because if x does become a half, then this whole part at the bottom becomes a 0, and that's undefined, which is not allowed. So your teacher might call this the restriction. Okay, so just remember to show that in the test. Okay, so now we've done number 2, so now we can go get our common denominator. If this is 1 over 1, then the lowest common denominator is going to be 2x minus 1. So that means we are going to multiply here by 2x minus 1, and what you do to the bottom, you always do to the top. And so that's going to give us x plus 1 over 2x minus 1 plus 2x minus 1 over 2x minus 1 equals to 0. When you have an equation and the denominators are all the same, you can cancel them out. So we can just say this now. And now we simply solve. So that's going to become 3x plus 0 equals to 0. And so 3x is equal to negative 0, which is just 0 actually. And so if you divide by 3, you're going to find that the answer is 0. Is there anything wrong with that? Not at all. You can definitely get an answer where x is 0. So here we have another fraction question, and remember what's important about this is that you need to find a common denominator, and you also need to look for your restrictions. So the restrictions, if we do that first, must be that this mustn't be 0, so we'll say x minus 1 equals to 0, so x equals to 1, therefore x must not be equal to 1, because if it was, then that bottom part would become a 0, and then we also mustn't let 3x plus 1 equal 0, and so if you had to solve that, you would find that x is negative a third, so therefore x must not be negative a third. Then for the lowest common denominator, these two things are not the same at all, so all that we do is we say that the lowest common denominator will be x minus 1 multiplied by 3x plus 1. So what that means is that you're going to have to multiply this one with 3x plus 1. You're going to have to multiply this one with x minus 1. And then this 4 is currently 4 over 1, so you're going to have to multiply that by x minus 1 and 3x plus 1. Now what you do to the bottom, you also have to do to the top. So now what we're going to end up with is x times 3x plus 1 minus, and then in brackets, 2x plus 4 multiplied by x minus 1 plus 4, and then both brackets, and that's equal to 0. Kevin, where's your denominators? Guys, you don't need denominators. Because it's an equation and the denominators are the same, we can leave it just like that. So now we're going to end up with 3x squared plus x. Now, this one's a bit more complex, so I'm going to say minus, and then I'm going to open up a bracket, and I'm going to multiply these two together, so that's 2x squared plus 2x. You might say minus 2x plus 4x, but eventually you should get a plus 2x minus 4. Then you're going to say plus 4, and then you're going to get 3x squared minus 2x minus 1, and that's all equal to 0. Now we need to go ahead and multiply the brackets one more time, so we multiply the minus inside like that, and now I'm just going to simplify. So 3x squared plus 12x squared, minus 2x squared, is going to be 13x squared, and then x minus 2x, that's minus x, minus 8x, that's minus 9x, and then plus 4 minus 4, that just gives us 0. Well, yeah, it cancels out, and so we can say equal to 0. Now what we do is we take out a common factor of x, and so you're left with 13x minus 9, and so here we can say that x equals to 0 because of that, or 13x minus 9 equals to 0, and so we can say that x is equal to 0, or 13x is equal to 9, and if you solve that, you'll get that x is equal to 9 over 13. So with question 17, what you want to do first is always look at your denominators and see which ones can first be factorized. So what you should identify is that this over here is a difference of square. And so we know that that should be 2x minus 3 and 2x plus 3. That's just your difference of squares. Now we've got some nice denominators. We've got this one and this one, which are exactly the same. You might be saying, Kevin, they're not the same. We need to switch them. But guys, remember that when you plus, for example, 5 plus 3 is 8, and 3 plus 5 is 8, the order doesn't matter. If it was a minus, then we would have to be careful. So those two are actually the same. Then we've got a 2x minus 3 and a 2x minus 3, so those are the same. So our lowest common denominator is just going to be 2x minus 3 and 2x plus 3. So this one here already has everything. This one, literally that one, is going to need both of the denominators. This one is going to need the 2x plus 3, and this one is going to need the 3 plus 2x. I mean the 2x minus 3. And so guys, if you look carefully, I've gone and added everything that needs to be added. So for example, this one didn't have a 2x minus 3, so I multiplied it with a 2x minus 3, top and bottom. This one didn't have a 2x plus 3, so I did it there. This one didn't have any of them, and then this one had both. Okay, so if you have to pause the video right now, do that. Make sure you understand what I've done. Please, guys, make sure you know exactly what I've done. Okay, now all of the denominators are the same, so we can ignore them. So now what we have is x, 2x minus 3, plus x, 2x plus 3. Notice I'm not multiplying anything out just yet. I'm doing it very stepwise in order to avoid having to make silly little mistakes. There we go. Now I can multiply the x in here, so that's going to be 2x squared minus 3x plus 2x squared plus 3x. Now here is where a lot of students make mistakes. You've got to be careful here. There is 1, 2, 3 things. So what I would do if I was you is leave the minus 1 alone. And trust me guys, this is where the people make the mistakes. You say minus 1, and then you multiply these two brackets together. Like that. And then in the next step, we can put the minus 1 in. Don't try to do it all in one step. So that's going to give us 2x squared minus 3x plus 2x squared plus 3x minus 4x squared minus 6x plus 6x plus 9 equals to 5x. Okay, so now we can simplify a little bit. So what happens here is that these x squares actually cancel because 2 plus 2 is 4 and then minus 4. And then these x's cancel. And then these cancel. My goodness, so we actually just end up with 9 is equal to 5x. And so x is going to be equal to 9 over 5. And that is our only answer. But something I forgot to do in the beginning was to look at the different restrictions. Now remember, a restriction is where your denominator is not allowed to be 0. So the restrictions that we should have had here was that 3 plus 2x should not equal 0. And also 2x minus 3 must not equal 0. I don't have to worry about this one because that one is actually this over here. And we are already taking care of it with these two. So if I have to quickly go solve for x now, it would be 2x equals to minus 3. And so x would equal to negative 3 over 2. So x is not allowed to be minus 3 over 2. And then for this one, you would find that x is not allowed to be 3 over 2. So what that means is we should quickly go to our answer that we got. Oh, okay, good. So luckily, this answer is not equal to any of the restrictions, and so we are okay. We don't have any problems happening here, and so the final answer is 9 over 5. So this is now question 18. Remember, step 1 when you have fractions is to check the bottom and to make sure that it's all factorized. This is not factorized, it's a difference of square, and so if you do the difference of square there, it's going to be 1 minus x and 1 plus x. Okay, now I want you guys to be careful. Oh, we should have done our restrictions first. Sorry, remember your restrictions. Well, actually, no, we can do it just now. I'll show you a little trick. So these two, they are the same because when you plus, the order doesn't matter. However, these two are not the same because when you minus, the order does matter. So there's various ways to do this. You can either make this 3x a minus, or you can make the 2x a minus. I'm going to make the 2x a minus, and so what happens is that we're going to get minus 2x. So because I took out I made it a negative, I can switch this around like that. And then this is still minus 6. And then this one I don't have to switch. Okay, so there is, so now everything's working nicely because x plus 1 is the same as 1 plus x. So I'm just going to change this one to x plus 1 actually, just to make it a bit easier to understand. And so our lowest common denominator is going to be 1 minus x and x plus 1. Now your denominator must never equal 0. So you can just say 1 minus x multiplied by x plus 1. We're doing it in a little different way to what we previously did, but this is just so much easier. We make that we don't want that to equal 0, so then x would equal to 1 or x equals negative 1. So we don't want those answers because those are our restrictions. Your denominator must never be a 0. So you don't have to go do your restrictions from the beginning here, because otherwise you might have to think, or you might think that you got to do this one, you got to do this one, and you got to do this one. But if you realize that once you found your lowest common denominator, a lot of them were actually the same as each other. For example, these two were the same, and these two were nearly the same. What that means is you only have to go check the lowest common denominator, and you can check your restriction from that. Alright, Kevin, you're talking too much, I hear some of you probably saying right now. So let's carry on. So we've got our lowest common denominator. So all you do now is you look at this one, and you ask yourself, what is that one missing in the lowest common denominator? Well, it's still missing an x plus 1. So we're definitely going to have to multiply a little x plus 1 over here and at the bottom. And then this one, what is that missing? Well, that's missing a 1 minus x. So we just put this at the top. We put like that. And then this guy over here, he's all good. It's all good because it's got everything in the denominator, so we don't need to do anything there. Now, because we are busy with equations, we can ignore the denominator. So we can literally just go, thanks, denominator. See you another time. And so what we then are left with is minus 2x multiplied by x plus 1. Notice I'm not multiplying out just yet. That's where students make mistakes. You want to do it step by step. Now I'm going to multiply out. So minus 2x squared minus 2x minus 6 plus 6x equals to 3x. Can then take everything to the left or to the right. It doesn't really matter. I'm going to take everything to the right. And then that's going to give us this plus 2x plus 6 minus 6x. So that's going to give us 2x squared plus 5x. Oh no, there's another minus 6. So that's going to be minus x plus 6. Okay, now we need to factorize this. Now you could use the quadratic formula. You know the whole minus b plus minus b squared minus 4ac over 2a. Or if you're brave, you can try factorize that one yourself. And guys, what you're actually going to find, no matter which method you do this, there is no way to solve this thing. And so this thing has, we're going to say no solution. That does happen sometimes, so don't stress if it happens. Obviously, if it does happen in a test, you want to double check yourself, but it is no solution for this one. If you used the formula, you would have gotten an error. Alright guys, so with this question, remember you need to get a common denominator. And so you need to always see which things can be factorized first. So this is a difference of square. And so that's going to be x plus 6. And then the difference of square here is x minus 2 and x plus 2. Then you can say plus 1 over x plus 2 equals to 2 over x minus 2. So it's very easy to see here that our common denominator, or our lowest common denominator, is going to be x minus 2 and x plus 2. And from that, we can actually get our restriction by saying that the denominator must never equal to 0. So then we say x minus 2 equals to 0, or x plus 2 equals to 0. And so therefore x must never be equal to 2, or x must not be equal to negative 2. So what that means is that later on when we get our answer, we should just make sure that it's not equal to one of those. Okay, so now because this is our common denominator, we don't need to do anything with the x plus 6, but this one needs the x minus 2. So I'm going to squeeze that in quickly. So what I've done now is I've just gone and given everything, made sure that everything has the same common denominator. Now because it's an equation, I can ignore that. So I'm going to just scratch out the denominators. Okay, now what you do is you just go write everything else out so long, like that. Now we simply multiply everything through. So that's plus x minus 2. Oh, this is an easy one. I don't even think we're going to get a square. And so what this is interesting. So now what we're going to find is that 2x plus 4 is equal to 2x plus 4. If you had to try to get x alone, you're actually going to end up with 0 equals to 0. Now, guys, 0 is equal to 0. So when you get an answer like this, you can say that x can be any real number. This is not going to be a no solution. It's a x equals to any real number. But remember our restrictions. X must not equal to 2 or x must not equal to negative 2. So this is actually an excellent question. So here's number 20. Step 1, make sure that all the denominators can be factorized. Or at least make sure that they are factorized. That's what I meant to say. So this one is a trinomial. And so that can factorize as x minus 3 and x plus 1. Okay, so these two are the same. But these two are very different. The reason is that when you minus, the order does matter. So what we do is, for example, we're going to take this one and we're going to turn it into a negative. So we're going to put a negative in the front and then we can switch it around. So let me actually show you that on the next step. So it's going to become negative 1 and then we can switch that around. Mathematically, that's the way you do that. Okay, so there we go, guys. So our common denominator, LCD, is going to be x minus 3 and x plus 1. And from that, we can get our restriction by saying that that should not equal to 0. So if we solve, we're going to get x minus 3 equals to 0 or x plus 1 equals to 0. And so x must never equal 3 or x must never equal to negative 1. So later on, when we get our answer, we must just make sure that it's not one of those. And so now what we do is we make sure everything has the common denominator. So we should have a look at this one. That one still needs to be multiplied by x plus 1. So we put an x plus 1 and then at the top. And then this one here still needs an x minus 3, top and bottom. And then this one already has everything. So that one's good. Now in the next step, we can just cross out the denominators. And now just write out whatever you have at the top. Don't try to do any of the brackets yet. I see a lot of students try that and then they make mistakes. Just write it out like that first. Now start multiplying in. So minus x minus 1 minus 2x plus 6 equals to x squared plus 7. I'm going to take all these things to the right hand side. So we get x squared plus 1x plus 2x plus 7 plus 1 minus 6. And so we're going to end up with x squared plus 3x plus 2. That can easily be factorized as x plus 2 and x plus 1. And so we'll find that x must be equal to negative 2 or x must be equal to negative 1. But guys, look over here. That is one of our restrictions. And so we'll say no solution for that one. And so therefore, x is only equal to negative 2. With question 21, the denominators cannot be factorized any further. And so straight away we can say that our lowest common denominator will be x plus 1 and x minus 7. And so all that means really is that this one still needs to be multiplied by x minus 7 and this one still needs to be multiplied by x plus 1. So you would end up with something like that. Oh, and our restriction would be that x plus 1 and x minus 7 would make that equal to 0. And so that means x minus 1 equals 0 or x minus 7 equals to 0. And so for this one, we could say x must never equal to negative 1 or x must never equal to 7. So we must make sure that we don't get those answers at the end. Now that our denominators are the same, we can just ignore them. And so now what we can do is just write out whatever's left over. Okay, so now we can just multiply out. So that's going to become x squared minus 7x minus 2x plus 14 equals to 2x squared plus 2x plus x plus 1. And then we can just take everything to the one side. I'm going to go to the right hand side. So you're going to end up with 2x squared plus 3x plus 1 minus x squared plus 7x plus 2x minus 14. And that would eventually give us x squared plus 12x minus 13. Now this one looks quite easy to factorize. So it's going to be x plus 13 and x minus 1. And so therefore x is going to be equal to 1, or x is equal to negative 13. Is that part of our restrictions? No, it's not, because this is a minus 1, and so these are going to be the two answers. So remember, with these questions, you always want to make sure that your denominators are as factorized as possible. So this one is not factorized, so let's do that first. That'll become x minus 5, x minus 2, then there's this plus 2, over x minus 4 and x plus 5. So what would the lowest common denominator be? Well, that would be x minus 5 and x plus 2. So from that, we can get our restriction, because we know that with a restriction, your denominator must not equal to 0. So we can say that x minus 5 must not equal to 0, or x minus 2 must not equal to 0, and so therefore x must not equal to 5, or x must never equal to 2. So later on, when we get our answers, we must just make sure that it's not that. Okay, so now we need to make sure that everything has the same denominator. So this one still needs to be multiplied by x minus 5 and x minus 2, and this one needs to be multiplied by x minus 2. So that's going to look like this. This first one has the denominator already, so we'll leave it as it is. The second one will need both. And then the last one needs the x minus 2. Like that. Now that the denominators are the same, we can ignore all of them. And then just rewrite everything that you have. Don't do any multiplying in or anything like that. Just rewrite everything for now. Okay, now we can start multiplying in. So we're going to say 3 plus. Now, guys, here's where a lot of people make mistakes. There's 3 things over here. Can you see that? My advice always is to do these 2 first, and then just leave the 2 outside. Okay, and that's going to give you x squared minus 2x minus 5x plus 10. Then you can multiply these 2 together. That'll give you that. Now in the next step you can put the 2 inside. And now it's just a matter of simplifying. So on the left side here, we're going to have 23 plus 2x squared minus 14x. And on the right hand side, we're going to have x squared minus 6x plus 8. I'm going to take everything to the left. Where we're going to end up with something like this. You might do this in a different order than I do. That's perfectly fine. And so that's going to give us x squared minus 8x plus 15. Oh, and this can be factorized as x minus 5. But if you need to use the formula, the quadratic formula, you can also do that. And so therefore x is going to be 5, or x is going to be equal to 3. But now we should always go up to our restriction, 5 and 3, and let's see if we have any of them. Oh, guys, look at that. I wonder how many of you got caught out. X is not allowed to equal 5 due to that restriction. So we'll just say that that's no solution. Therefore, x can only be equal to 3. With question 23, we can instantly see that the denominators are factorized, and so we can go get our lowest common denominator as 2x minus 3 and x plus 1. So from that, we can get our restriction by saying that 2x minus 3 equals to 0, or sorry, shouldn't equal to 0. Sometimes I put an equal sign, sometimes I put a not equal to. You guys know what I'm trying to do. X plus 1 is not equal to 0. And so if we had to go solve, it would be 2x is equal to 3, and then you could get x is equal to 3 over 2. So x must not equal to that, and then x must also not equal to minus 1. So just now when we get our answers, we must just make sure that it's not equal to any of those. Okay, so our lowest common denominator is 2x minus 3 and x plus 1. So this one is going to be multiplied by x plus 1, this is going to be multiplied by 2x minus 3, and this is going to get both. So it's going to look like this. So we have something like that now. Now because the denominators are all the same, we can just cancel them out. And then whatever we left with, just go write that down. Don't try to solve it yet. I know I'll mention this in almost every video, but I'm trying to get you guys to see something. Okay, now this little 1 in the front, I'm just going to ignore that because that doesn't really do anything. Now we can multiply the brackets in, so it's x squared plus x plus 8x minus 12. Then this is 2x squared plus 2x minus 3x minus 3. I'm going to take everything to the right, and so that's going to give us 2x squared minus x minus 3, because I just put those two together, minus x squared minus x minus 8x plus 12, and that's eventually going to give us x squared minus 10x plus 9. And so we could factorize this as x minus 9 and x minus 1, and so therefore x will be 9, or x can be equal to 1. Now that's not the same as the restrictions, and so we are all good. That is our answer. So here's question 24. Now the denominators have already been factorized, so straight away we can say that the LCD is x plus 1 multiplied by x minus 4, and so if we look at the restriction, you would eventually find that x must not equal to minus 1, or x must not equal to 4. So later on when we get our answer, let's just make sure we don't get that. So I'm just going to quickly rewrite everything here, just to make it a little bit more spacious. So this one still needs x minus 4, this one still needs x plus 1, and this one is going to need both. So that's going to look like this. Alright, and then over x plus 1 and x minus 4. Now the denominators are the same, so we can cancel all of them because it's an equation. And then remember guys, just write everything down. Don't try to do anything yet. That's where the mistakes happen. Okay, so we now have that. So now what we do is we can multiply the 12 into the bracket, and so 12x minus 48 minus 6x minus 6 equals to minus 4 times by x squared minus 4x plus x minus 4, and so we can just solve a bit. And you see how I did this one, by the way, I didn't mention it. There was 3 things over here, so I did the brackets first. So now I'm going to put the minus 4 in, so it's minus 4x squared plus 16x minus 4x plus 16. And so now I can simplify a bit, so it's going to be 6x minus 54 equals to minus 4x squared plus 12x plus 16. And so then what happens is we can take I'm going to bring everything to the left, so we're going to have 4x squared plus 6x minus 12x minus 54 minus 16, and that's going to give us 4x squared minus 6x minus 70. And then to be honest guys, I wouldn't try factorize this. I'm a bit lazy with these types of ones. I would just use the quadratic formula. And what we're going to get eventually, depending on whatever method you want to choose, you should get x is equal to 5, or x is going to be equal to negative 3.5. Now we go up to our restrictions, and our restrictions simply told us that x can't be those. So we're good. We didn't get any of those answers, and so this is our final answer. Number 35 is our first square root equation. Now remember, if you've watched any of the previous videos on square roots and how to handle these, they're very easy. This is actually really easy marks. What you want to do is you want to get the square root alone. So here the square root already is by itself. Then you just want to square both sides. In maths you can do that as long as you do it to both sides. Now the square of a square root cancels out the square root, and so you're just left with x plus 3, and then on the right you're left with 16. Then you simply go ahead and solve, and you'd end up with x equals to 13. What's very important with square root equations is you should always check your answer. The reason is that square roots can sometimes give you an error on the calculator, so you have to check it. The way that you check it is the following. You take the answer and you plug it into the equation wherever you see x. So let's just quickly say left hand side is going to be 13 plus 3. Now that's equal to the square root of 16, which is 4. And the right hand side, well, that's just a 4. So is the left hand side the same as the right hand side? Yes. So this answer works. So with number 36, we have another square root equation. Now I said in the previous question that you always want to get the square root alone, but I don't mean like this. This is okay. What you don't want is something like this, for example. You see, because now this minus 4 is with the square root. That's a problem. But when the number is in front of it like that, you don't have to move it away. It's okay. All that you do is you do what we normally would have done, and you square root both sides of the equation. And so what is the square root, the square of 2? Well, that becomes a 4. And then what is the square of a square root? Well, the square root just falls away, and so you're just left with x. And then on the right hand side you have x squared. Okay, now to solve something like this, you take everything to the one side, take out x as a common factor, and so your two answers will be x equals to 0, or we can also say x is equal to 4. Now remember, we have to do our little check. So to do a check, you take your answers and you put them into the equation. So when x is 0, let's check that one first. So the left hand side is going to be 2 times 0, and that equals to 0. And then the right hand side, you would just plug that x value on the right, and that's also 0. So the left hand side is equal to the right hand side, so everything's good. Now we're going to check if x is equal to 4. So what you do is you plug it into the left hand side of the equation, and so that's going to be 2 square root 4, which is just going to give you an answer of 4. And then on the right hand side, you plug in the x value, but that's also 4. So once again, the left hand side is the same as the right hand side, so everything is good. There's no problems here, and so those are our two answers. Step 1 with a square root equation is to try get the square root alone. If there's a number in the front, that is perfectly fine. So what you do to get rid of the square root is you square both sides of the equation. Remember, in maths you are allowed to do that as long as you're doing it to both sides. So the square of 4 is 16, and then the square of a square root, well, that just takes away the square root, and so you're just left with whatever's on the inside, like that. Then a common mistake that students make is over here they just say 9x squared plus 64. If you've just done that, it's okay, it's normal, a lot of students do that. But what you need to remember is that it's a double bracket. So you got to go like that and like that. Okay, so now I'm going to multiply everything in. So that's going to be 16 multiplied by 4, which is 64. X plus, now 16 multiplied by 9, what's that? I think 144. Let's double check. Yep, 144. And then you multiply the brackets out. So that's going to be 9x squared plus 24x plus 24x plus 64. Okay, so now we take everything, I'm going to take everything to the one side. And so you're going to have this like that. Alright, and so 0 is going to be equal to 9x squared. Now I'm going to put all the x's together, so it's 24 plus 24 is 48, minus 64 is negative 16x minus 80. Now you can divide by, you can try dividing by 9. I thought it was going to work, but it won't. You can try dividing by stuff, but what I like to do is I just use the quadratic formula. You know, the one that goes minus b plus minus b squared minus 4ac over 2a. If you haven't done that before, then of course you could also try factorizing this, using the brackets. And whatever way you will use, you're going to get x is equal to 4 or negative 20 over 9. Now, I'm not going to write this as a decimal just yet, or I guess I can. It's okay. So it'll be negative 2.22. Now remember, you need to do your little checks. So I'm going to divide my page in half. So if x is 4, let's check if that works. So if x is 4, then the left-hand side, you're going to plug 4 into the original equation. So it's going to be 4 square root of 4 times 4 plus 9. And I'm just going to type that on my calculator. Then I'm going to check out the right-hand side. And that's going to give me 3 times 4 plus 8, which is also 20. So the left-hand side is the same as the right-hand side, and so everything's good so far. Now, when you're doing the check for the decimal part, this is important, guys. You don't want to plug in the decimal, because the decimal is rounded off, and that's not going to give you an accurate reflection over here. So you need to remember that when we did this one, we actually got an answer of negative 20 over 9. You want to use that when you do your check, okay? Because remember, if you've rounded off, you've taken away some of the accuracy, and so you might find that this won't work out. The left-hand side won't be the same as the right-hand side, but meanwhile, it actually might have been if you just used the proper fraction. So for the left-hand side, I'm going to go plug it in as 4 multiplied negative 20 over 9 plus 9, and that gives me 4/3, or 4 over 3. Now for the right-hand side, you use the same value, so it's just 3 times negative 20 over 9 plus 8, and that's also 4 over 3. But now if you went and used the decimal version, they would have been a little different. Okay, so the left-hand side is the same as the right-hand side, so we can say that this x equals to negative 2.22. We can use that as our final answer, and x is also 4. So with question number 38, we have a square root, and so we need to get that square root alone first. So there it is. So we can do this. Then we can take the 2x over to the other side. And now what we want to do is we want to square both sides. Like that. Now remember that if you square a square root, it just cancels the square root, and so you'd be left with the inside part like that. And then the square of this becomes 4x squared. Now it's easy. You just take everything to the one side. So I'm going to take everything to the right. And then we solve using the quadratic formula, or you can try factorize if you're brave. Oh, this one can actually factorize, but anyways, x would equal to 0.25, or x would equal to negative 2. If you did want to use factorizing, it would have gone 4x minus 1 and x plus 2. Okay, but you would still get the same answer. Now, I hope some of you have remembered that when we have a square root question, you need to check your answers, right? So let's just erase all of this. So, well, let's keep it there just in case some of you are still writing that down. So we need to do a little check. Whenever you have a square root question, you must do a check. So what you do is you take each of these. I'm going to take the first one. So if x equals to 0.25, then we need to work out the left-hand side of the equation. So I'm going to plug it into there. And so that's going to give me the square root of 2 minus 7 times by 0.25 plus 2 times 0.25. And that gives you a value of, gives us a value of 1. Now we look at the right-hand side and look at that. It's equal to 0. So the left-hand side and the right-hand side are not the same. So this one is actually a no solution, or it's not applicable. Okay, now we need to go and check this one. So I'm going to do that in a different color. So let's go do a little check over here. and we say if x equals -2. So now we're going to go left-hand side. And so that's going to give us the square root of 2 minus 7 times by, -2, Kevin, -2. And then plus 2 times by -2. And if we go work that out, it gives us 0. And the right-hand side is also 0. So because the left-hand side is the same as the right-hand side of this equation, everything's good, and so this is our answer. So with 39, we have a square root. Luckily for this one, the square root is already by itself, so we can immediately square both sides. And so remember that when you square both sides, it gets rid of a square and a square root. They cancel each other out, and so you're only left with that. And then 4x squared is actually 16x squared. I'm then going to take everything to the right. I would then use the quadratic formula, and we'll find that x is 1, or x equals to -0.94. But now here, this is very important. When we go and do our check, you must not use this answer in the check. You must use the version that was not rounded off. If you look on your calculator, it was actually -0.9375, or you could even use the fraction, which was -15/16. So use this one or this one when doing your little check that we're about to do, but never use the rounded off one. Okay, so let's go do our checks. Let's start with if, and why are we doing a check? Because there's a square root. So if x equals to 1, then the left hand side of that equation is going to be 1 plus 15. And that equals to, if you work that out in the calculator, that's going to be 4. Now if we look at the right hand side, it's going to be this part, which is 4, multiplied by x, which is 1, and that equals to 4. So the left hand side is the same as the right hand side, and so this answer, it works. This one works nicely. Now let's go check the other one. So let's do it here. If x equals to -0.9375. So for the left-hand side, that's going to look like this. -0.9375, because I'm plugging it in the place of x, plus 15. And if we go work this out, it gives us 3.75. And now if I go plug that in on to the right-hand side, which is this part, it's going to give us 4 multiplied by -0.9375, and that gives you -3.75. So these two answers are not the same, so we'll say that the left-hand side is not the same as the right-hand side there, and so this answer is not valid. No solution for that one. Alright guys, so in question 45, we have to solve for x using the quadratic formula. Now, if the quadratic formula is new to you, in grade 11 it's a brand new concept, then let me quickly write out the formula. Alright, and let me quickly show you how it works. You always want the one side to be equal to 0. Once that is true, then the number that is in front of x squared, which is a 1 in this case, that'll always be a. So a is always in front of x squared. B is in front of x, so b would be -3. You must include the negative if there is one. And then c will be the other number, which is -7. Okay, and then what you do is you just go fill that into the formula. So x equals to, then the formula says minus. Now look at b, it's -3, so you put a -3. Then there's a plus minus. Now go in brackets for this one, and that's going to be -3 squared minus 4. Now the formula says a comes next, which is 1, and then c, which is -7, like that. And then at the bottom it's 2 multiplied by a, which is 1. There we go. So look how I've used brackets wherever I used a, b, and c. If you can follow that, you'll get this correct every single time. Now some of you watching this might be like, Kevin, my calculator doesn't have a plus and a minus at the same time. Neither does mine, but luckily we don't have to do it at the same time. What you want to do is you want to use plus. So let's use a plus first. So I want you to go type all of this on your calculator, but by using a plus over there. And so I think I'll do this with you guys for now. So the formula starts with a minus, and then you put a bracket, then it's minus 3. Then we're just going to use a plus for now. Then there's a square root. Then there's brackets. Minus 3, close the bracket. Minus 4, bracket, 1. Oh, I think that minus 7 is a little bit off your guys' page, but you guys know what's meant to be there. Sorry about that. So it's minus 7. And then at the bottom, we just have a 2 bracket times by 1. It's as easy as that, guys. I just followed the formula, and then I say equals, and then I push SD, and there's my answer to 2 decimal places. So it's 4.54. Just remember that. I'm not going to write it down just yet. Then what I do is I go backspace, 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 backspace on my calculator 100 times, and then I change this one to a minus, and then I push equals, and there's my next answer, minus 1.54. And so guys, our 2 answers that we found were 4.54, and then the other one was negative 1.54. In question 46, we need to solve using the quadratic formula, which, remember, we said in the previous question goes like this. Now remember, to use this formula, you need a 0. Do I see a 0 here? Nope, there's no 0. So what I want to do first is I want to make that 0 by moving everything to the one side. Now I have my 0. When I've got the 0, then a is the number in front of x squared, b is the other number is in front of x, and then c is the remaining number. So a will be 2, b will be minus 3, and c will be negative 13. Then you literally just go and type that in on this you type it into the formula, but let me show you what it would look like. So be careful here. So there's a minus, so we put a minus, then a bracket, and then b is minus 3. Then I say plus minus. Now b is minus 3, but I must always use a bracket wherever I plug something in. A is 2, c is negative 13, like that, and then at the bottom I've got 2 times a, which is 2. Now I take my calculator and I type it exactly like that. So I'm going to type it exactly as I see it. So it's going to be minus 3, like that, plus the square root. See how it says plus and minus, but you can only do one at a time. Notice how I'm using brackets every time. Then there's a minus 13. Then at the bottom it's 2 times 2. There we go. Then I push equals, SD, and there's our answer. So x is going to be equal to 3.41. I'm just going to write it on my paper for now. Then to get your other answer, you push backspace 100 times. It feels like 100 times. And then you change it to a minus. That's how you get your second answer. And it's going to be minus 1.91. And so the 2 answers that we get is going to be 3.41 or x equals to negative 1.91. 47, we have to use the quadratic formula, and I'll quickly write that down for us. Step 1, make sure you have your 0. We do have a 0, so everything is good. So then a is always the number in front of the x squared, so a will be 5. B will be the number in front of the x, which is minus 3. And then c will be everything else, which is minus 8. You then type that in on the formula, but let's first fill it in. So just do it directly, or exactly as you see it. So there's a minus, then you put a bracket, and then b is minus 3. Then there's a plus minus. Then b again is minus 3, but look, I use a bracket. A is 5, and then c is negative 8, and then 2 times 5. Now we get our calculators, and we type it exactly as we see it. So let me quickly move that up. See, there's a minus, then there's a bracket, then I use a plus. You can't use a plus and a minus at the same time, so you just use a plus for now, and then there's a bracket. Guys, promise me that you'll just fill it in exactly as you see it. Don't try anything else. Otherwise, you're going to start getting errors on your calculator and all sorts of weird stuff. Okay, so there's our first answer, but I'm going to use the decimal. So x equals to 1.6. And then to get the second answer, you go backspace a few times until you get here, and then you change it to a minus. Because remember, they said it can be a plus and a minus. And there's our next answer, minus 1. And so x is going to be equal to 1.6, or x is going to be equal to negative 1. So here we have to solve this equation using the quadratic formula. Now your quadratic formula is this one. But remember, step 1, before you are allowed to use that formula, is you need to get your 0. We don't have a 0 here. So to make a 0, you're going to take the minus 10 over. So it's going to be negative 3x squared plus 7x plus 10 equals 0. Once you have your 0, then everything is good, because then you can get your a, b, and c. A is always the number in front of the x squared, so a will be minus 3. B is the number in front of the x, which is a 7, and then c is the other number, which is 10. You then go ahead and fill that on the calculator, or first let's put it into the formula. Let me show you how that works. So notice that there's a minus here, so we say minus, then in brackets we're going to put the 7, then there's a plus minus, then it's a bracket, always a bracket, and then minus 4, then a is minus 3, and then c is 10. And then at the bottom we're going to have 2, and then in brackets minus 3. So now you can type it into your calculator exactly as you see it. So that's going to be a minus, then there's a 7, then you're going to say plus. You can't use plus and minus, so you're just going to choose one of them at a time. Then that's a 7, minus 4, now there's a minus 3, then a 10, and then at the bottom you get that. And so that's our first answer, x equals to minus 1. Then to get your second answer, you go back to the plus minus part, and you choose a minus this time. And so there's your second answer, 3.33. And so x will have a final answer of minus 1, or x could be 3.33. In question 49, we're going to be using something called the K method. Now, in order to make sure that you don't miss this when you are in your exam, I'm going to show you a little trick. Let's pretend you didn't realize that this is actually a K method kind of question. Then how else could you have solved this? Well, you might have realized that there's a fraction, so we need a lowest common denominator. So we could say that the lowest common denominator is x squared plus 3x plus 2, or you could even factorize it if you wanted to do that. All right. Now technically, each of these are over 1, so you would need to multiply them with the common denominator. So let's just look at this first one. This first one you would have to multiply by x plus 2 and x plus 1. And then the bottom would be x plus 2 and x plus 1. So let's just stop right there. Can you see that if you had to go and multiply this together, you would end up with an x to the power of 4. Now here is my advice. If you reach x to the power of 4, you have gone too far. So we've gone too far, so we go back to the beginning. And all that we need to do is check this out. Have a look here. You can see that this part is exactly the same as that part. There's a repetition over there, okay? So what we do is we say let x squared plus 3x, let's call that a different letter. Now for some reason, these weird mathematicians, they've gone and chosen k. That's why we call it the K method. So there's nothing special about the letter k, they just decided to do that. Okay? Haha. So moving on, so we know that that is now going to be replaced with k, so that's going to be k plus 7 equals to 6 over k plus 2. See what I've done there? I've just replaced the x squared plus 3x with k. Now I can solve this like a normal equation where there's a fraction. So the lowest common denominator here would be k plus 2. And so this one is over 1 and this one is over 1. So we're going to have to do k multiplied by k plus 2. It's like getting a lowest common denominator like we normally did in the previous questions. Alright, you see that. So now that the denominators are all the same, we know that we can cancel those out. And so I'm just going to multiply the k in, but we won't get a k to the power of 4. So we happy because we don't want to get that. Now we're just going to solve for k, pretending that it looks like it's the same as x. So I'm going to bring this 6 over. And so that would give us k squared plus 9k plus 8. Now this can easily be factorized as k plus 8 and k plus 1. So therefore k is minus 8 and k is minus 1. But now we're not done, guys. You've just gone and found k, but you haven't yet found x. But what you do now is you must remember the following. We did this earlier on, so now we can use that. So let's start with the first one where k is minus 8. So we can say if k is equal to minus 8, then I'm going to plug that in over here. So we're going to get x squared plus 3x equals minus 8. Now we just solve this as per normal. So we bring that 8 over like that, and now we solve. Now I'm just going to use the quadratic formula because it's nice and easy. Oh, and we actually get no solution over there. That's pretty awkward, or no, it's anticlimactic. So we just say no solution for that one. Then you're going to use the minus 1. So you say if k equals minus 1, then you're going to plug that in over here. So we're going to say x squared plus 3x equals to negative 1. You then bring it over. And then we go use the quadratic formula again. This one has answers. So we can say that x is equal to negative 0,38 or x equals to negative 2,62. And so there we go, guys. That's our first k-method question in this worksheet. In question 50, you might have been tempted to multiply these brackets together, and there's nothing wrong with that. But did you notice that you would end up with an x to the power of 4? Now remember, in the previous video, or the previous question, we said that when you end up with x to the power of 4, we've gone too far. There needs to be a better way. And so let's have another look. What we should realize here is that this part is the same. So what we do is we just say let x squared minus 4x equal to k. And so we replace that with k minus 1 minus, and then in brackets, k squared. Now we can just say k minus 1 minus k squared equals to minus 13. And now it's easy. We just solve for k. So I'm going to take everything to the right-hand side. And that would eventually give us that. And then this should be able to factorize like that. And then k would be equal to 4. Or k would be equal to negative 3. Now that's not the answer, but we're halfway there. So what we now do is we realize that earlier on we said this. So now we can take each of these k answers and just plug them into there. So we can say if k equals to 4, then we can say x squared minus 4x equals 4. See what I did? I just plugged the k over there. And then we can say x squared minus 4x minus 4 equals to 0. And then you can solve this with the quadratic formula. And so x is going to be 4.83, or x is going to be negative 0.83. Okay, so we've got two answers so far. Now we need to do this again, but now we're using our other x answer, which is, our other k answer, which is negative 3. So I'll squeeze that in here. If k equals negative 3, then we start the process again, like that. And then I bring the negative 3 over. I can then factorize this. That's actually going to be negative. And so therefore x is 1 and x is 3. So look at that, guys. It's pretty cool. We got 4 answers. 1, 2, 3, and 4. You might have been tempted to use this as a common denominator. Now that is not wrong. But what you would eventually realize is that when you had to multiply this up to this x squared, you would end up with an x4. And remember what we've said in previous questions is that when you get an x4, there's probably a better way to do this, and that'll typically be a k method. So don't worry about maybe not seeing it in a test. As soon as you get x4, then it's k method. So have a look here. You got to look for the repeating part, and there it is. So what we then say is let that part, let's call that k instead. So then what happens is that this whole part is k, and then we're going to say minus 8 over, and then k equals 7. Now we can get a common denominator, which is just going to be k. So this is currently over 1, and this is currently over 1. So it's eventually going to become k squared over k. I'm just getting common denominators now, guys, and then that's going to be 7k over k. Now the k's can cancel because they're the same, and so we end up with k squared minus 8 minus 7k equals to 0. I just took it over. I'm just going to quickly rearrange. I want the 7k next. And then this one can be factorized pretty easily as k minus 8 and k plus 1. And so k would be equal to 8, or k would be equal to negative 1. So that's not the answer, because remember, we're trying to find x, but we've just found k. But we're halfway there, because now what we can do is we can use this first one. So we can say here, if k equals to 8, then what we do is we use this, and we will say x squared plus 2x equals 8. Now we solve for x, so x squared plus 2x minus 8, and this can be factorized as x plus 4 and x minus 2. And so if you had to solve that, you'd get x is equal to minus 4 or x equals 2. Now we can use the other k answer. So if k equals minus 1, then we can say x squared plus 2x equals minus 1, and that's going to be x squared plus 2x plus 1. And this can factorize as x plus 1 and another x plus 1. And so if you had to solve this, you would simply find that x equals to negative 1. And so there we got 3 different answers. With number 52, you might have been tempted to use this as a common denominator. It's not wrong, but then you would have eventually multiplied this one with an x squared. Eventually that would have happened, and you probably would have ended up with x4. Remember what we keep saying, as soon as you end up with an x4, it typically means that you've gone too far, or you need to use a different method, and it's typically the k method. So now what we do is we look for the part that repeats, and if you look carefully, it's this part here, it's the same. So what we then do is we say let that part, 2x squared minus 5x, let's call that k instead. So now what I can do is I can replace all of that with k minus 3 over k equals 2. Now we just need to get a common denominator, which is going to be k, because these are over 1 at the moment. And so that's going to give us k squared over k minus 3 over k equals to 2k over k. Now the k's cancel because they're all the same. And so we now have k squared minus 3 equals to 2k. I'm going to take the 2k over. Now we can factorize like that, and then we'll find that k is equal to 3 or k is equal to negative 1. So now that's not our answer, we're trying to find x. So what we now do is we come back to this, and we take one of these k's at a time. So we can say here, if k equals 3, then what happens is we say 2x squared minus 5x equals to 3. See, I just plugged it in the place of k. And now we say 2x squared minus 5x minus 3 equals to 0. I would use the quadratic formula here to solve. Oh, nice answers. X equals to 3 or x equals to negative a half. Then we're going to use the other k value, so we can say if k equals negative 1, then we can say 2x squared minus 5x equals to negative 1, and so 2x squared minus 5x plus 1 equals to 0, and then we use the quadratic formula again, and so x is going to be 2.28, or x is going to be negative 0.22. Alright, and so there's 4 different answers. Here in number 53, if you had to multiply these two brackets together, you would have ended up with x4. Now that would remind you, oh wait, it's probably the k method. So what we do is we look for anything that's repeating. There it is, and there it is. So we then say let x squared minus 5x equal to k, and so we replace everything, or that part, with k. See what I did? I just replaced it with k. I didn't change any brackets or anything like that. I'm now going to say 9k plus 20 equals to negative k squared. I'm going to bring the k squared over to the left, like that. This one factorizes nicely as k plus 4, k plus 5, and so therefore k would be equal to negative 4, or k would be equal to negative 5. Now remember, that's not the answer. What we now do is we come back to here and we say if k equals negative 4, then we plug that over here. So we'll say x squared minus 5x equals to negative 4, then x squared minus 5x plus 4, and then you can make your double brackets and you can say x plus 4 and no, minus and minus. There we go. So x equals to 4 or x equals to 1. Now we need to use this one over here. So we can say if k equals to negative 5, then we could say x squared minus 5x equals to negative 5. And so x squared minus 5x plus 5 equals 0. Now this one, I don't know how nicely this one will factorize, so I would use the quadratic formula here. And this one gives us x equals to 3.62 or x equals to 1.38. And so there's our answers. In question 54, if you used a common denominator approach, eventually you would have hit x4. Now remember, that usually means we've gone too far, and so we need to rather use the k method. So if we look carefully, this part and this part is the same. So all that we say now is let x squared minus 4x, let's rather call that k. So now what we do is we go replace all of these things with k, so it'll be k equals to 17 minus 60 over k. Now we get a common denominator, because these are technically over 1. The common denominator is going to be k, so it's going to be k squared over k equals to 17k over k minus 60 over k. Now the k's cancel because they're all the same, and so we end up with k squared equals to 17k minus 60. We're then going to take it all to the left. Now this does actually factorize, but you could use the quadratic formula. It would be k minus 12 and k minus 5. I'll be honest, I didn't see that at first. I just used the formula. So k is 12 or k is equal to 5. So now what we do is we realize that that's not the answer. We need to now come back to this. And so what we can now say is if k equals 12, then we can go work out x. So we can say x squared minus 4x equals to 12. And so x squared minus 4x minus 12 equals to 0. And this one does factorize pretty nicely as x minus 6 and x plus 2. And so x is going to be equal to negative 2 or x is going to be equal to 6. Then we can do the other one. So we can say if k equals to 5, then we can say x squared minus 4x equals to 5. Bring the 5 over. And this one will factorize like that. And so therefore we can say that x is 5 or x equals to negative. To solve an inequality, I pretty much want you to think of this as the same as a normal trinomial, like if you had x squared minus 7x minus 8, and you can pretend that that was an equal sign. And so if that was the case, you would have factorized over here as x minus 8 and x plus 1. Now a huge mistake, or the biggest area where students make mistakes now, and if you've done this it's okay, just remember that this is wrong. You don't want to do this now. You're not going to say x minus 8 is smaller than 0 or x plus 1 is smaller than 0. That is not correct. I think I used to do the same back when I was in high school, so I do understand that that's tempting, but that's not the way it works. What you want to do instead with inequalities is you want to now open up a little number line for yourself. Okay, now what would the answers be here? It would be, if this was, for example, if this was an equal sign, what would your answers be? Would you agree with me that your answers would be 8 and -1? Right, now what you do is you come back up to this parabola that you have here, and you ask yourself, you should know that that is a parabola, right? You can remember that from last year. Whenever you have a graph or a function where you've got an x squared, it's a parabola. Now a parabola can be happy, see it's a smiling face over here, or it can be sad. Okay, so that's a sad face. So when the number in front of the x squared is a positive, which in this case is just a +1, then it's happy. Why? Positive means happy, negative means sad. Positive happy, negative sad. So we draw a little smiley face going through the two numbers that we just looked at, like that. And then we ask ourselves, or we have a look here, it says, where is this parabola smaller than 0? So it's saying, where is this parabola negative? Now what that means for a graph is, when they say where is the graph negative, it means underneath. So that means it's underneath over here. And so your answer is going to be from -1 up to 8. It's going to be inside that interval over here. So mathematically you would have to say that x can be any number that is between -1 and less than 8. If you prefer interval notation, you would say that x is an element going from -1 up to 8. With a inequality, you want to solve this like a normal trinomial. So you would open up your two brackets, and you would say that x minus 4 and x plus 1. But then I said in the previous question that a very big mistake that students make is they try to do something like this. Okay? I know that that seems correct, but it's not. What you rather want to do is the following. You need to now draw a number line, and you need to ask yourself, if this was an equal sign, then what would your two answers have been? Well, you would have said x equals to 4 and x equals to -1. So you go put those numbers on your number line. Then what you do is you look at this graph, and you should know from grade 10 that that is a parabola. Remember, a parabola can be smiley face, or it can be sad face. Now, the way to know is to look at the number in front of the x squared. If it's positive, then it's happy, so it's smiling. Positive, happy, smiling. If it's negative, then it's sad or upside down. So negative, sad, positive, happy. So we have a happy graph here. So we draw a happy graph. Now what we do is we look at this part over here, this part, and it's telling us where is this graph negative or smaller than 0. Remember, smaller than 0 means negative, so it means where is it underneath the x-axis. So underneath the x-axis is all of this over here, and so your answer is going to be from -1 up to 4. So you're going to say that x must be bigger than or equal to -1 or smaller than or equal to 4. Why am I saying bigger than and equal to and smaller than and equal to? That's just because that's what they gave us. If you prefer to do interval notation, then you would rather write it like this. You would say x is an element, and then you'd use a square bracket from -1 up to 4 with another square bracket. With number 62, you want to take that 4 over to the left-hand side first, so I'm actually going to write it over here. And then you can make it bigger than 0. Now what you do is you just pretend that this is an equal sign, and so you could factorize this. And this would factorize as x minus 4 and x plus 1. Now, as I said in previous inequality videos or questions, is that what some students want to do here is you want to say that x minus 4 is bigger than or equal to 0, or x plus 1 is bigger than or equal to 0. I know it's tempting, but it's not correct. So what you want to do instead is, if this was an equal sign, what would your two answers be? Well, it would have been that x equals 4 or x equals to -1. So now what I want you to do is to draw a number line and put those two numbers on the number line like that. Then what you do is you look at this over here and you ask yourself, what type of graph is that? Well, that is a parabola, right? And you get two types of parabolas. You get happy parabolas, which are always smiling, and you get sad parabolas, which are always sad. Now, the way to tell if we have a happy or a sad is to look at the number in front of the x squared. If it's positive, it's happy. If it's negative, it's sad. So because this number is technically a positive 1, it means it's happy. So we can draw ourselves a happy parabola, like that. And then we need to look at this part here. It says that, where is this parabola bigger than 0? So larger than or equal to 0. So when it says bigger than 0, it means above. Let me just quickly summarize that for you. Bigger than 0 means above. Smaller than 0, you guessed it, means below. So this one is above, so it's going to be this area over here and this area over here. But now you want to get all the x values, so it's going to be all of these x values here and all of these x values over here. So the way that you would do that is you would say that x can be any number that is smaller than or equal to -1, which takes care of this, or, now we need to do this side, x can be anything that's bigger than or equal to 4. If you prefer to do interval notation, then you would say that x is an element going from -infinity up to -1 with a square bracket because we are including. Then you could say or your teacher might do this funny symbol here. You could say that x is an element going from 4 to positive infinity, like that. Question 63 is quite interesting. So there's many different ways that you could do this one, and I'm going to show you both of those ways, okay? So I'm going to put a line down the center of the page. And the first option, what a lot of students like to do is they don't like this negative. I understand, I've seen a lot of students do that. So if you did want to change it, so let's say this is option number 1, where you get rid of the negative, then it would become x squared minus 10x minus 11. But then what's very, very important with an inequality is when you divide with a negative, your sign must switch, so it will look like that. Now what you do is you just do the sum from here. So you ignore this part now, and you only focus on this new thing that you've done. So we know that this is a trinomial, which will be x minus 11 and x plus 1. Now remember, you don't want to go say x minus 11 is bigger than 0 or x plus 1 is bigger than 0. What you rather do here is you do a number line, and your two numbers, well, what would the answers be? It would have been 11 and minus 1. So we put minus 1 here and 11. You know, if you had to solve it like a normal equation, if this was an equal sign, your two answers would be 11 and minus 1. So we can put that over there. And so now, oh no, that's the wrong sign. Let me quickly rewrite that. So now what you do is you need to know, is it a happy or a sad parabola? So you don't go back to this part now. You simply look at this part. And so that's a happy parabola because there's a positive number in the front. So we draw ourselves a little happy parabola. And then we look at this part. It says, where's the happy parabola bigger than 0? So that means above. So when they say above, it means this section and this section, because you can see the green line is above. It's above the x-axis. Okay, so the answers are going to be that x is somewhere here, so we can say x is smaller than minus 1, or, and now your teacher might use or like that, do whatever your teacher does, x can be anything greater than 11. If you prefer interval notation, you could say x is an element from minus infinity up to -1, or x is an element going from 11 to infinity. Alright, now if you choose option number 2, so factorizing this next part can be a bit more tricky, I will admit. So it's actually going to have a negative x and then an x, 11 and a 1, and then we'd want this one to be positive, and also this one will be positive. So that might take you a little bit of time. So that's maybe why you would prefer to use the positive method. But pause the video and see if you can understand how this all works. And so now we just draw our number line, and we get our two answers. So if you had to solve this, you would get 11 and minus 1. See, so that's going to be the same, minus 1 and 11. That'll be exactly the same as this one. But now what we have is, let me quickly write this original. But now what we have here is a sad parabola. See that? So we draw a sad parabola this time. Like that. Now they're saying, where is the sad parabola negative or smaller than 0? So that means below. So below is going to be this area and this area. So looking at the x values, that would be all of this and all of that. So our answers would be that x is smaller than minus 1, that's this part, or then this part is x is bigger than 11. If you prefer interval notation, you'd say x is an element from negative infinity to negative 1, or x is an element from 11 to infinity. So what I want you to clearly see is that you get the same answers at the end. Because think about it. Here we're looking at a happy parabola. So happy. But then we looked for where is it positive, so that means happy and above. This one we looked for sad and below. So it's sort of the same thing. Happy and above is going to be the same area where you have sad and below. So you're going to get the same answer. You must just do whatever's comfortable for you. I do know that most of you prefer the first option, and so for the rest of this video or these questions, I will focus on that type of way. Alright guys, so here we're going to do simultaneous equations to solve for x and y. So simultaneous equations are actually very easy. All you do, step 1, is get x or y alone. So you just want to get x or y alone. So I'm going to take this equation over here because we already have y alone. Can you see that? Step 2, plug that into the other equation. Okay, so if for example we call this top one equation 1 and we call this equation 2, let me rather call this A and B just to not cause any confusion here. Okay, so what we did is we did A, we got x or y alone, so we got this alone. Now we put that into the other equation. So what we do is we go to the other equation, I'm just going to write it out, and we're going to replace this y, because it says here that y is equal to this. So we're going to put this in the place of y. So we're going to end up now with x squared plus 2x plus 4 plus 3x equals to 8. So what you guys should identify here is that I have taken this, and this little glitter writing, I didn't know that was a glitter pen, and I've put that over here, which is in the place of this y over there. Now it's easy. That's the difficult part. So now what we do is we just solve. So we're just going to say x squared plus 5x, let me write that a bit better, 5x plus 4 minus 8, because I'm bringing the 8 over, equals to 0, and then it's x squared plus 5x minus 4 equals to 0. And then you solve. Now I'm going to use the quadratic formula. I don't think this one solves very nicely. No, it doesn't. So we find that x is equal to 0.7 and x is equal to negative 5.7. Okay, so now we have our two x answers. And so what we can now do is we need to find our y answer. So we can say here, if x equals 0.7, then we can easily find y by just using this one over here, because it says that y is equal to, now in the place of x you're going to say 0.7, and let's see what we get, 5.89. Then we can do the other one, so we can say, let's do that in a different color, let's go with this black color. So if we say if x equals to negative 5.7, then we do the same thing. Y equals to negative 5.7. Notice I'm using a bracket. Negative 5.7 plus 4. And if we had to go work this out, we end up with 25.09. So our final answers are going to look like this. when x is 0.7, then the y value for that one was 5.89. So we do like that. Or then your other answer, when x was minus 5.7, then your y value was 25.09. And so there are the answers for this question. So here's another simultaneous equation. And so what we need to do is step 1, get, how did I say get and then I write x? That's interesting. Get x or y alone. That's all you need to do first. Oh, and let's call this equation 1 and equation 2. If we look at equation 2, we actually have y alone already. So, yeah, we already have y alone. So all we're going to do now is we're going to plug number 2 into number 1. So remember, step 1, get x or y alone. We've done that. That's already done for us. Now what you do is you put that into the other equation. So let me quickly write the other equation down for us over here. Now you see where this y is? You're going to be able to replace that now with x squared minus 15. Okay, because it says here that y is equal to x squared minus 15. So we're going to replace it. So what this will now look like is 2x minus, then in brackets you're going to say x squared minus 15 equals 7. And now it's just a case of solving. So I'm going to bring everything to the right hand side. And so that's going to give us x squared minus 2x. And then plus 7 minus 15 is negative 8. Now this can solve or factorize nicely as x minus 4 and x plus 2. And so therefore x is 4 or x is negative 2. But now that's not the final answer, because the point of a simultaneous is to get x and y. So we can say here, if x equals 4. If x equals 4, let me do that in a different color. Then what we can do is we use this equation over here. Then it tells us that y should be equal to 4 squared minus 15. See, I'm just plugging the x answer into here. And so that means y would be 1. Now, in a different color, if x equals to negative 2, then you plug it into the same equation. Then y would be negative 2 squared minus 15. And so that would be negative 11. And so our final answers for this entire question are going to be the following. So when x was 4, y was 1. When x was minus 2, y was negative 11. So here in question 69, step 1, get x or y alone. And it doesn't matter what you get alone, but I'm going to go for this one. Oh, but let's first call this equation 1 and equation 2. So I'm going to take equation 1 and I'm going to rearrange it. So we're going to have, let me just write it down here first. And I'm going to try get that y alone, because it's so nice and easy to get. It's by itself already, so you just have to move stuff to the other side. So it's going to be 5x minus 3. Now, because we've rearranged it to make a brand new equation, we'll call this number 3, just to help the teacher who's marking understand what's going on. So now what we're going to do is we're going to plug or substitute number 3 into the equation that we haven't used yet. You're not going to plug it into number 1, because you've already used that one. Right, you already used it over here. You're going to plug it into the other equation, so we're going to plug it into number 2. So what does this actually mean? You're going to take this expression, which says that y is equal to 5x minus 3, and you're going to replace all the y's with that. So it's going to now look like this. 5x minus 3 minus 3x squared equals to 6x minus 7. Can you see what we've done? Let's go through this slowly together so you understand. Step 1 was to get y alone. So I took this equation and I wrote it over here again. And then I just rearranged it a little bit to get the y completely alone. I then took that expression and it says that y is equal to 5x minus 3. And so I replaced this y with 5x minus 3. And that's what we can see over here. Everything else is the same. Now we can go ahead and solve. So I'm going to take everything to the right, and so we're going to end up with 3x squared plus 6x minus 5x minus 7 plus 3. And so that's going to be 3x squared plus x minus 4. I'm going to use the quadratic formula now. Oh, nice answers. X equals to 1 or x equals to negative 4 over 3. Now we know that negative 4 over 3 in decimals is actually negative 1.33. But when we fill in the x equals to minus 4 over 3 into the other equation, I would recommend using the fraction because it's the most accurate. You don't want to round off and then plug it into the y. Okay, so we found our x answers. Now we need to go get our y answers. And the one that we use is this one here. It's so nice and easy. So we can say that if x equals to 1, then y would be equal to 5 times 1 minus 3, and so y would be equal to 2. Then if x equals to negative 4 over 3, then y would be equal to 5 times negative 4 over 3 minus 3, and that gives us negative 9,67. Okay, so there we're done. So our final answers are the following. So when x is 1, then y was 2. Or when x was, now we can use the decimal, minus 1.33, then y was negative 9.67. And so in question 72, we are given an equation, and they said one of the roots. Now let's pause there. What do roots mean? Roots have different meanings in maths, but it means, or not different meanings, but different words, or different understand. You can say it's the answers. You can call it the x-intercepts. And yeah, those are mostly what you can think of when you think of roots. So they tell us that one of the answers is minus 1. So if, for example, I gave you something like this, and I made that equal to 0, and you went ahead and you factorized this as x minus 4 and x plus 1, your answers would be x equals to 4 and x equals to minus 1. These are called the roots. Now, what that actually means is that you were trying to make this side equal to 0. Okay? And mathematically, there are two numbers that you could use that will make that true, either 4 or minus 1. So what that means is that if you had to plug 4 into here, it would equal 0, because that's one of the answers. So what it means for us in our question over here is that if you plug in minus 1 in the place of x, it should make this equation true. So we can so they tell us one of the roots is minus 1, so we can plug that in, so minus 1. And then we don't know what k is, but we know that the whole answer should be 0. And then we can just say 1 plus 7 plus k equals to 0. And if you had to go solve for k, you would see that k is equal to negative 8. And now that's question A. Now question B says determine the other root. So determine the other answer. Well, what we do now is we can go fill in that negative 8 in the equation. And now we just go and do our normal factorizing. And we'd find that x minus 8 and x plus 1 if you had to factorize that one. And so x is 8 or x equals negative 1. Now check this out, guys. We already knew that one of the answers was negative 1. But now we found the other one. So the other answer is going to be x equals to 8. In question 73, we are given an equation. And they tell us that one of the roots is 3. Now remember, a root actually just means an answer. Or if you're later on in this in grade 11, you might think of it as an x-intercept of a graph. So it's an answer. So what that means is that if you plug x inside of this equation, it will make the equation true. What that means is it will make the answer equal to 0. So you do the following. You take that answer of 3 and you plug it into the place of x. Like that. So that's going to give us 9 plus 3k minus 21. And now we can solve for k. So we're going to end up with 3k equals to 21 minus 9. And so 3k is equal to 12. And then if you divide by 3, k is 4. Okay, so we know what the value of k is. So now it says find the other root, or find the other answer. So all that you do now is you go plug that k value back into the original equation, and now we can do our normal factorizing. And so that will be x plus 7, x minus 3. And so the two answers will be minus 7 or x equals to 3. Now look at that, guys. X equals to 3. We already knew that that was one of the answers. So the other answer we are looking for is x equals to minus 7. In question 74, we are given an equation, so kx squared minus 5x plus 3, and one of the roots is 1. Now remember, a root is actually just a fancy word for answer. And later on in the year when you do graphs, it's also a fancy word for x-intercept. Okay, so it says here, determine the value of k. Well, it tells us that one of the answers is 1. So what you do is you take that number and you plug it into the place of x, like that, and then you solve for k. Now, if you had to do this, you would find that k is equal to 5 minus 3, and so k is equal to 2. Then for question B, it says determine the other root, which is the same as saying determine the other answer. So if k is 2, then it will be 2x squared minus 5x plus 3. And then you can just solve for this using the quadratic formula, or you can factorize. It's up to you. I'm going to use the quadratic formula, and I'm going to get x equals to 1.5 or x equals to 1. Now we already know that one of the answers was x equals to 1, and so this is the other answer that we're looking for. So therefore the other root is x equals to 1.5. Questions like 75 are actually very easy to do, so let me show you something quickly. Let's pretend we had the equation x squared minus 3x equals to 4. Minus 4 equals to 0, and then we had to solve that. Well, you would probably use these two brackets, and you'd say x minus 4 and x plus 1, and then you'd get that x is equal to 4 or x equals to minus 1, right? That's easy. We've been doing that since like grade 10, grade 9 even. Now, check this out. If you are given the answers, for example, if they give you the roots, remember roots actually just mean answers. Then you just have to reverse the brackets. So let's say they give you x equals to 4 and x equals to minus 1. Then you put them into two brackets, but you say x minus 4 and x plus 1, and then you multiply it out to go to the very beginning. So we can go forwards and backwards. See that? So in this question, they're giving you this, so you go back to that, and then you go back to that. So if x is equal to minus 3 and x equals to 4, then you can make two brackets by saying x plus 3 and x minus 4 equals to 0. And then you just go ahead and multiply that all out. And then you go simplify, and there is your answer over there. So there's your quadratic equation. It'll be x squared minus x minus 12. Before we do number 76, in case you didn't watch 75, I want to quickly show you the idea behind a question like this. Let's say I gave you an equation x squared minus 7x minus 8, and I asked you to solve. Well, you would develop two brackets, and you would say x minus 8 and x plus 1, and then you would get that x equals to 8 or x equals to minus 1. These are your answers, but they are also called your roots. So, if they give you the roots, then you just have to work backwards. So look how you work backwards. You go back to the first step where you make the brackets. So if your answer is 8, then in the bracket you would use minus 8. And then if your answer is minus 1, then in the bracket it would be plus 1. And then what you do is you just multiply out those two brackets to get back to the original. Easy, right? So what we're going to do is if x is minus 2 and x is minus 3, then we're going to make two brackets, but it'll be x plus 2 and x plus 3. Like that. And so then we can go ahead and multiply everything out, and that's going to give us x squared plus 3x plus 2x plus 6 equals 0. And then that would be x squared plus 5x plus 6. And there's your answer. You see what we did? So we took the answers that they gave us, we turned those into brackets, we multiplied out the brackets, and so it's almost like we're going backwards. In question 77, we are told that we have a rectangle with a perimeter of 20, Okay, so what we could do is make a perimeter. Well, there's a rectangle, and the perimeter is the distance around, and that should be 20. So what I like to do is I call this x. So that means this would be x, this would be then what be y, like that. Now the perimeter is when you add everything together. So I would say that when you plus them together, so 2x's plus 2y's should give me 20. Then it tells us that the area is 24. Now the area would be x times y. So the area would be x multiplied by y, but they've told us that that is 24. And there we go, guys. Now they say determine the length and breadth, so that pretty much means determine x and y. And so 2 equations, 2 unknowns. Did someone just say simultaneous? Yes, this is going to be simultaneous equations. So remember, let me write these 2 equations underneath each other. This is number 1, this is number 2. And so with the simultaneous equations, your step 1 is to always try to find x or y alone. So get x or y alone. And then step B, let's not jump the gun here. Let's get x or y alone. So what I'm going to do, it doesn't really matter. I'm going to get x alone in this equation. So I'm going to say that x is equal to 24 over y. And then I'm going to call that equation number 3. So then what you do is you put the new equation that you've just made into the equation that you haven't used, into equation which has not been used. Okay, so that means we're going to plug number 3 into the one that we haven't used, which is number 1. So wherever we see an x, we're going to replace it with 24 over y. Okay, and then I'm going to multiply out, so that's 48 over y. Remember that this 2 only goes to the top. Plus 2y equals to 20. Now we simply have a common denominator. That common denominator is going to be y. And so we're going to multiply everything by y. So this will stay 48 over y plus 2y squared over y. See, because I multiplied top and bottom with y, equals to 20y over y. Now that we've got y's everywhere, we can ignore them, or I mean at the bottom. And then we have 48 plus 2y squared equals to 20y. I'm then going to take it over. Well, I'm going to bring the 20y over, I should rather say, like that. Now, you can use the quadratic formula here, but I'm going to first divide everything by 2. We are allowed to do that. There we go. And this one will actually factorize quite nicely. It's y minus 6 and y minus 4. And so therefore y would be 6 or y would equal to 4. Now that we have our y values, we can now go get our x values. So what we then do is we use number 3 again. So if y is equal to 6, then x would be equal to 24 over 6, which would be equal to 4. And then in a different color, if y was 4, then x would be equal to 24 over 4, which would be 6. So our final answers will be x equals to 4 and y equals to 6. That could be your answer for this rectangle. Or x could be equal to 6 and y would be equal to 4. So let's see if it makes sense. If, let's say for example, x is 4, let's erase that quickly. If x was 4, then they tell us that y would have to be 6. And so the perimeter would definitely be 20 and the area would also be 24. And so your final answers will be these over here. Question 78 can be handled really easily. I'll show you exactly what to do. We've got a person who's going to ride a bicycle. So from A to B, they're going to go that way. And then they are going to come back. On the way from A to B, they tell us that the average speed is 10 kilometers per hour. So that's how fast the person is cycling. And then on the way back, they cycle at 16 kilometers per hour. Then it says find the average for the entire journey. Now, I know for a fact, I know even I thought about it like this back when I was in high school. If it's 10 kilometers going that way and 16 going that way, then isn't the average simply going to be 13? Because 13 is directly between 10 and 16. It turns out that that is not true, and the reason is the following. I want you to think about this carefully. Which of the speeds, 10 or 16, will the person cycling spend more time doing? Would they spend more time at the 10 kilometer per hour speed, or would they spend more time at the 16 kilometer per hour speed? Well done if you said the 10, because think about it. They're cycling a little bit slower, so they're going to take a little bit longer to get from A to B, so they're going to spend more time doing 10 kilometers than they are 16 kilometers. So because they're going to spend more time at the 10 kilometer per hour speed, we will find that the average is going to be closer to 10 than to 16, because they're spending more time doing that. So the way to handle this is the following. You should know that speed is equal to distance over time. So what you do is you handle this equation, speed equals to distance over time, but you do it for the entire journey. Okay. So they tell us that the distance between A and B is W. So that's W, and then coming back is also W. So what is the total distance that this person is going to travel? It's not W squared, it's just W plus W, which is 2W. Okay. Now, for the time to go from A to B, we need to be careful. So I'm just going to say time from A to B plus the time from B to A, because that's your total time, right? But now we need to look carefully at how to calculate the time from A to B. Well, we should know that time is equal to distance over speed. So for AB only, it's going to be W, and the speed is, what was the speed from A to B? It was 10. Now your time from B to A is also going to be distance over speed. And so that's going to be W, but over 16. So then what I'm going to do is I'm going to take those two expressions and put them into here. And so what we're going to find is that the average speed is going to be equal to 2W over W over 16 plus, sorry, W over 10 first, plus W over 16. Now, what happens is the following. At the bottom, you should put those two together. So you could almost think of it like this. Speed is equal to 2W over, now this is 1 over 10 W plus 1 over 16 W. You can think of it like that if you want. And so you're just adding the bottom together. It's 1 over 10 plus 1 over 16. And so that's going to give us 0.1625 W. Now what's really cool is that these W's are just going to cancel out. And so the average speed is going to be 2 divided by 0.1625. And that's going to give us 12.31 kilometers per hour. And didn't we say that the speed is going to be closer to the 10 than the 16? And so 12.31 kilometers per hour is our final answer. Question 79, also a very easy kind of question, but it is a little bit difficult when you see it for the first time. But you might have to watch this question 2 or 3 times, but once it clicks and once you understand the way to do it, it's very easy. So what we have, and I think pictures do help in these types of questions, what we have is 2 pumps that are filling up a swimming pool. Okay, so here's a swimming pool. And let's just draw the level like that. And what we have is a pump. So, you know, like a pump that they use to pump water. So there's our first pump, and we'll call that pump A. And then we've got another pump filling from the other side, and we'll call that pump B. It says that the 2 pumps could fill up this pool in 5 days. Okay, so if these 2 pumps are operating together, this pool could be filled up in 5 days. Alright, I hope you just understand that part. That's important. The two pumps, when they are working together, can fill up a pool in 5 days. If pump A fills up the pool alone, it would take X days. Now, do you think X is going to be more than 5 or less than 5? Well done if you said more. Because pump A and pump B can fill up this pool in 5 days. Now, if pump A is working by itself, it would obviously take a little bit longer. And then they also tell us that pump B would take 2 days longer than B if working alone. Okay, so for example, if pump B can do 6 days by itself, then pump B does 8 days. Alright, so I hope you understand the question. I hope you understand that pump A is the stronger one, because it can fill the pool in X days, whereas pump B can fill it up in X plus 2 days, right? Because it takes 2 days longer. Now here's the secret with these types of questions. I want you to think about 1 day. Alright, now when let's go pump A and B. If pump A and B, here's the key, guys, this is the part you really need to pay attention to. If pump A and B work together, they can fill up this pool in 5 days. So then what fraction of the pool could they fill up in 1 day? Well done if you said 1/5 of the pool. 1/5 they could fill up in 1 day. Because if they fill up 1/5 on 1 day, 2/5 on 2 days, 3/5 on the third day, 4/5, and then 5/5, which is 1 whole. So in 1 day, pump A and B can fill up 1/5. Okay, what about pump A? If pump A can take X days to fill up an entire pool, how many days would it, or what fraction could it fill up in 1 day? Well, it would be 1/x. For example, if it takes 10 days, then in 1 day it can fill up 1/10. So if it takes X days, then it can fill up 1/x. And what about pump B? Well, it would fill up 1/x plus 2. So now, surely in 1 day, if you can add up what pump A does and you plus it to what pump B can do, then that'll be how much they can both do. So we can say pump A plus what pump B can do would be pump A and B together. So we can say 1/x plus 1/x plus 2 should give us 1/5. Alright, you might need to go and watch that part a few more times. Not many of you are going to get that the first time because it's quite complex. Okay, so if you have gone and rewatched that a few times, and now I assume you guys are understanding where we are going, now all of a sudden we have a fraction equation, and so we need a common denominator. The lowest common denominator here, or the LCD, is going to be x plus 2 times 5. So I'm just going to put the 5 in the front. So that means we are going to have to multiply this one over here with 5 and x plus 2. But then what you do to the bottom, you must do to the top. This one we're going to have to multiply with 5 and x. But what you do to the bottom, you do to the top. And then this one we're going to have to multiply with x and x plus 2. And what you do to the bottom, you must do to the top. So we're going to end up with 1 multiplied by 5 multiplied by x plus 2 over x times 5 times x plus 2 plus 1 times 5 times x over x plus 2 times 5 times x equals to 1 times x plus 2 over 5 times x plus 2. Now that the common denominators are all the same, we can ignore them. And so we simply end up with 5 multiplied by x plus 2 plus 5 multiplied by x equals to x multiplied by x plus 2. And so now we can multiply the 5 in, so it's going to be 5x plus 10 plus 5x equals to x squared plus 2x. And so it's going to give us x squared plus 2x minus 5x minus 10 minus 5x. So I'm going to make that equal to 0. And then we can solve for x. So it's going to be minus 3, so it's minus 8x minus 10. And so I'd use the quadratic formula here and find that x is going to be 9. If we round this to 2 decimals, it's actually going to be 10, or x is going to be negative 1.10. Now remember, x is the amount of time needed for pump A, so you can't have a negative times. That'll be a no solution over there. And so pump A takes 9.1 days if it works by itself. So pump A alone will be 9.1 days. And then pump B, if we remember correctly, pump B takes 2 days longer. So pump B, if it works by itself, it'll take 11.1 days. And then if they work together, then of course they take less time, and that's when they take 5 days. But there's the answers for this one.